Hello and welcome to the lecture for the second class of week 3 for Math 131. First thing we're going to be looking at today, of course, we're getting into chapter 10 and looking at geometry. We're going to be looking first at complements and supplements. Most of you will remember these from high school, but remember that complements sum to 90 degrees. Take a look what we have here. We've got a right angle. You can tell it's a right angle by the little box right there. We know that the measure all the way across is 90 degrees. We've got an angle of 62 degrees here, and we want to know what that angle right there with the question mark is. So we would simply say 90 minus 62 equals, what does that equal? It equals 28 degrees. So those two angles are complements. So 28 and 62 are complements. So this angle here with the question mark would be 28 degrees. Let's take a look at another one. You can see that these two angles are complements, and I've got one angle that is 57.3 degrees, so I would simply say 90 minus 57.3 equals what? That equals, what does that equal? 32.7. Let's try that. 89, yep, 32.7 degrees. So the measure of this angle right here with the question mark would be 32.7 degrees. Now when we talk about supplements sum to 180 degrees because they're on a straight line here. That complete measure would be 180 degrees. So if I wanted to know the measure of this angle right here, I've got 111 degrees here. So I would simply say 180 minus 111, and that would give me what? 69 degrees. So 69 and 111 are supplements. Supplements add to 180 degrees. See if we've got another one here. Here, these two angles are supplements also. Let's see. I have trouble finding my pen here sometimes. Here it is. Since they're on a straight line, that complete angle there is 180 degrees. This one is 72.6. So to find the measure of this angle, I would say 180 minus 72.6. What does that give me? That gives me 107.4. 107.4 and 72.6 are supplements. 72.6 plus 104 should give me 180. And of course it does, 180 degrees. So 72.6 and 107.4 are supplements, and those are measures. All right, let's take a look and see what else we can look at here today. All right, find the complement and supplement of the following angles. Okay, find the complement and supplement of the following angles, 37 degrees. All right, as far as the supplement or the complement goes, we are simply going to say 90 minus 37 equals 53. So the complement of 37 degrees will be 53 degrees. The supplement, I would simply say 180 minus 37 equals 143. So the supplement would be 143 43 degrees. For the next one, 81.4 degrees. All right, to find the complement, I would say 90 minus 81.4 equals 8.6. So the complement of 81.4 degrees is 8.6 degrees. Let's find the supplement of 81.4 degrees. 180 minus 81.4 equals 98.6 degrees. 98.6 degrees would be the supplement. So complements add to or sum to 90 degrees. Supplements sum to 180 degrees. Now let's look at some basic geometry, some basic rules that we have in geometry. First of all, when we have vertical angles are equal. And you say, well, what are vertical angles? Anytime two lines cross, this angle and this angle, the ones across from each other are vertical angles. And this angle, let me put two lines there, and this angle are vertical angles. Vertical angles are equal. In other words, if you were given the following and asked to find angles 1, 2, and 3, first of all, I would look across from 68. And I know that angle 1 there is 68 degrees because angle 1 is vertical to 68 degrees. And then to find angle 2, look, 68 degrees and this angle 2, they are supplementary. So I know that angle 2 is 180 degrees minus 68. Let's see if we can do that. 180 minus 68 equals. So angle 2 will be 112 degrees. And of course, angle 3, I don't have to worry about. I could say, well, this is a straight line and supplementary to 68 degrees also. But now I know that angle 2 and angle 3 are vertical angles, so those are both 112 degrees. Let's look at another one. Let's say I was given the following. Let's say this is 132 degrees, and I was asked to find the measures of this angle, and this angle. Well, straight across from 130 degrees, this angle is going to be 132 degrees. Now, since this is a straight line right here, this angle is going to be supplementary to 132 degrees. So 180 minus 132, what does that give me? 48 degrees. So this angle would also be 48 degrees. Vertical angles, pretty simple. The only time that you might get a curveball on these is something like this, where you've got some vertical angles and they've thrown in a right angle in there on you. Let's say that they've given you this angle, and this angle is, let me see what I could say that is. Let's say that this angle is 38 degrees. And then they ask me to find the measure of this one. We'll call this angle 1. Call this angle 2. And call this angle 3. First of all, you've got to understand, since I've got the little square there, we know that this angle is 90 degrees. That one right there. Now, 38 is here. What is the angle straight across from it? It's this one. So angle 2 I know is 38 degrees. And also, since I've got this straight line going right down through here, I know that angle 1 and 38 degrees are supplementary. So angle 1 will be 142 degrees. Because 180 minus 38 is 142. So since this whole angle is 142 degrees, I know that this whole angle is 142 degrees. But I've got a right angle in there. So this angle 3 right here will be 142 minus 90, because I've got to take that right angle out of it. So it will be 52 degrees. All right, not too bad. That's about the worst kind of those that you will see. Now, the next thing we'll look at are parallel lines cut by a transversal. There's actually only 2 angles in there when parallel lines are cut by a transversal, and there's some rules. Alternate interior angles are equal, okay? Those are equal. And you say, well, what are alternate interior angles? Think about it. Think about this as the top. This is the bottom. Alternate interior angle 3 and angle 6 would be equal. Angle 5 and angle 4 would be equal. Alternate exterior angles are equal. Angle 1 is equal to angle 8 because they're alternate exterior or on the outside. Angle 2 would be equal to angle 7. And then corresponding angles are equal, but you can also see that 1 is on top and to the left, 5 is on top and to the left, 7 is on bottom to the left, 3 is on bottom to the left, 2 top right would correspond with 6 top right. There's only 2 measures in there in the whole thing. The best way to look at one of these is to take a look at an example. Let's say we've got these parallel lines cut by a transversal, and I know that this angle is 70 degrees. Based on that, I can find all of the other angles. Look at them. Angle 2, back to our vertical angle rule, angle 3 would also be 70 degrees. And then alternate interior angles are equal, so angle 6 would also be 70 degrees. Angle 6 is vertical to angle 7, so it would also be 70 degrees. Now look at angle 1 and angle 2, that's 70 degrees. They would be, since they're on a straight line, they would be supplementary. So angle 1 would be 110. Angle 4 would be 110 because those are vertical angles. Angle 5 would be 110 because those are alternate interior angles. Angle 8 would be 110 because those are alternate interior angles. So those are not too bad either. Now, let's look at another one. Let's say I've got a situation where I've got, let's go right here and put a right angle right there. So I know that's 90 degrees. And they tell you that this is 31 degrees. And then say find the measures of all the other angles. Well, think about it. This whole angle is 90 plus 31, which is 121 degrees. So angle 4 would be 121 degrees. Angle 5, since those are alternate interior angles, would be 121 degrees. Angle 8 would be 121 degrees. Now, angle 3 and angle 4 are supplementary because they're on a straight line. So what would that make that? 59 degrees. Angle 2 would be 59 degrees. Angle 6 and angle 3 are alternate interior angles. That would be 59 degrees. And then angle 6 and angle 7 are vertical angles. So that would be 59 degrees. Still not too hard there. All right, let's see what else we have to look at. Oh, the sum of the interior angles of a triangle is always equal to 180 degrees. So if they've given you a missing value like they have here, they say, what is this value? Well, I'm going to take a look at these and say 120 plus 17. 120 plus 17 gives me what? 137. So I know that this angle has to be 180 minus 137, because the sum of those interior angles of a triangle is equal to 180. So let's look at that. 180 minus 137 equals 43 degrees. Therefore, I know the measure of that angle right there is 43 degrees. Easy enough. And you say, oh gosh, how would I ever figure this out? Well, we're going to use everything that we've learned on this little geometry problem. First of all, let's take a look at it. I go in and I find the easiest ones first. I know since this has the square there, that is a 90-degree angle. And you think about it, that angle and angle 1 are supplementary angles because they're on a straight line, so this has to be 90 degrees. So now angle 2, what would angle 2 be? Well, I've got 90, 143, that adds up to 133 degrees. The sum of the measures of a triangle's interior angles is 180, so angle 2 has to be the difference of 180 and 133. 180 minus 133 equals, what's that, 47 degrees. So I know that angle 2 is 47 degrees. So I'm going to say, all right, that angle right there, I'll write it on top of it, 47 degrees. So that angle and angle 3 are vertical angles. So angle 3 has to be equal to, I'm going to put an arrow in there. Angle 3 has to be 47 degrees. Well, look at this little triangle now. I've got 47, 60, and angle 4. Those have to sum up to 180. So 47 plus 60 is 107. 180 minus 107 is equal to 73. So angle 4 will have to be equal to 73 degrees. That right there, angle 4. And since angle 4 and angle 5 are supplementary, angle 5 will have to be equal to 107 degrees. So we figured all of that out just using basic geometry. Now you should remember this. We can classify triangles either by their angles or by their sides. With acute triangles, all of the interior angles are acute angles. Acute angles are less than 90 degrees. So all of these angles are less than 90 degrees. A right triangle has a right angle in it. An obtuse triangle has an angle that is greater than 90 degrees. I like to call the obtuse angle the Andy Dufresne triangle, or the Andy Dufresne angle, if any of you have watched The Shawshank Redemption. But think about it, you can only have one obtuse angle within a triangle because an obtuse angle is greater than 90 degrees. If I had two, I would go over 180 and my sides would never meet. I could also classify a triangle by its sides. An isosceles triangle has two sides that are equal and one that is a different length. An equilateral triangle, all of the sides are equal in length. With a scalene triangle, all of the sides have different lengths, and you notice the tick marks. That just means they're different lengths, and if they have the same number of tick marks, they would have the same length. All right, similar triangles. I know I gave you a similar triangle discussion question this week. Similar triangles have common ratios. The thing about similar triangles is they have the same interior angles. Notice this one has one tick, so that angle is the same as this angle on the little triangle. This angle is the same as this angle. and this angle is the same as this angle. And they have common ratios. I've given you all of them here, but when I work these questions, I always work them big over little. It's kind of like a big brother and a little brother. In other words, let's say we did not know this one. Let's say there was an x here. Okay, so I would go with the big brother here. Let's see, 8. I know that it's 8. And that's the missing side for the little brother, x. That would be equal to the, just pick one of the sides here, 6 over 3, the corresponding side. And yes, I could have used 4 and 2. And then I simply multiply. Cross multiply. 8 times 3 is 24. X times 6 is 6x. Divide both sides by 6. And we see our answer is 4. And of course, we already knew the answer is 4. Maybe I've got one here where we don't know the answer. All right, this is a similar triangle problem. You say, Brent, how do you know that? Well, think about it. They've given me that these two angles are equal. These two angles are vertical angles, so they have to be equal. And if a triangle, two triangles have two angles that are the same, the third has to be the same because their sum is going to be 180 degrees. So these are similar triangles. So again, I'm going to say, well, they want us to find side x. We've just got to find the ones that correspond. Again, I put big over little. I'll spell it L-I-L. So my big one here, 8, is to 5. And you say, how do you know that? Because those two sides are between the same angles for each triangle. And then I'm looking for x is to 7 on the little one. So what would I do? I would simply cross multiply. 8 times 7 is 56. 5 times x is 5x. Divide both sides by 5. I'm going to have to get my calculator out. 56 divided by 5 equals 11.2. So I know that side x, these would cancel out, is equal to 11.2. So I found the length of side x. Okay. Oh, the Pythagorean theorem. I know you've been waiting on this, and you should remember this from high school also. The Pythagorean theorem says the sum of the squares of the lengths of the legs of a right triangle equals the square of the length of the hypotenuse. And what you've got to remember is the hypotenuse is always the side across from the right angle. A right triangle can be oriented, various ways, but if you just remember that the hypotenuse is across from the right angle, you'll be fine. So if I've got sides or legs A and B, and those are the sides coming out from the right angle, with the hypotenuse C, the lengths A squared plus B squared equals C squared. Let's look at one of these. For this one, so we're looking for C. So remember, A squared plus B squared equals C squared. So I would have 12 squared plus 9 squared equals C squared. 12 squared is 12 times 12, which is 144. 9 squared is 9 times 9, which is 81. I'll leave my C squared here. I add 144 to 81. 144 plus 81 equals 225. You said, well, how do I figure that out? I take the square root of 225 and the square root of c squared, because when I take the square root of c squared, I get a plain old c. So let's see what the square root of 225 is. I'm going to hit my square root button, and it is indeed 15. So side C is 15 by the Pythagorean theorem. Let's see if I've got another one here. Yeah, here's another one. This will be a little bit more difficult because on this one I'm missing side A. All right, so I have a squared plus b squared equals 18 squared. I'm sorry, equals c squared. I got to do a control Z here. Equals c squared. I'm getting ahead of myself. So I have a squared plus 10 squared equals 18 squared. A squared plus 10 times 10 is 100 equals 18 squared. I have no idea. I'm going to have to look this one and put it in the calculator. 18 squared is 324. So these are a little different when I'm solving for A or B, because I'm going to have to subtract 100 from both sides. And I get a squared equals 224. I got to find the square root of 224, so I'm going to put in 224, hit the square root button. 14.97 rounded to 2 decimal places, so I will say square root A equals 14.97. So it would be 14.97 centimeters. We nailed it. Now I'm moving on to section 10.3, chapter 10, section 3. There is a couple of things here that are important that I want you to know. The things about, we're not really going to get involved into tessellations that much, but I do want you to know about perimeters and one other topic that I'll cover on the next chart. So perimeters are just the distance around. Say I've got a rectangle that is 11 by 18. Think about it. This side would be 11 also. This side would be 18. So if I sum those up, I would see the distance is 2 times 11 plus 2 times 18 to get the perimeter, the distance around. 22 plus 36 gives me 58 centimeters. So the distance all the way around that rectangle would be 58 centimeters. Triangle, this is a little isosceles triangle here. What would be the distance around? 10 plus 10 plus 5. So the distance around that triangle would be 25 inches. The perimeter would be 25 inches. Here I've got a pentagon. Simply add it up. 6 plus 6 is 12 plus 8 is 20 plus 5 is 25 plus 8 is 33. So the perimeter of that pentagon would be 33 millimeters. Now here's the other topic that I want you to know. There's a little formula that you can use to find the sum of the measure of a polygon's interior angles. It's simply n minus 2 times 180 degrees. Think about it. A triangle has 3 sides, so 3 minus 2 is 1. 1 times 180 is 180. So you know a triangle has interior angles summing to 180. So I've got a problem. Find the sum of the measures of the angles of an octagon. An octagon has 8 sides, so I would say 8 minus 2 times 180. I would get 6 times 180. I can put parentheses around that, but it gets kind of messy. I'll have to use my calculator. 6 times 180 equals 1080 degrees, so 1080 degrees would be the sum of the measures, some of the angles of interior angles of an octagon. I think I've got one more here. Of a pentagon. How many sides does a pentagon have? 5, so I would say 5 minus 2 times 180. So that would be 3 times 180. Get out my calculator. One more time. 3 times 180 equals 540. So that would be the sum of the interior angles of a pentagon. That's all I have to cover today. Hope everyone is doing well. Look forward to seeing you in the classroom. Take care now.